Hello guys, today I'm going to show you my setup on a V8 engine on my SI2000, Snap-on SI2000. This is a tool that you can actually get the ignition waveforms. This is the 5.3 GM, it's a coil near plug system, which means that each plug has its own coil, but there is a spark plug wire in between, so we can hook up our leads to ignition pickups to each spark plug. I've been using this now for a couple of weeks and trying to learn more about it and what the limitations are, and something that we learned last time on my last video, which I'm going to leave a link in the description, is that whether you are using all of these cables, you need to keep them all plugged into this tool. Use this on a BMW, on a straight V6, straight 6 engine, and one of these cables was unplugged and my power kV was off. So it has to do something with the internal impedance of this tool. My friend Robert from Texas, he figured that out, and if you unplug this cable and if you unplug the cable, maybe this one from the positive side, and you're using this cable to get your ignition waveform, the power kV is going to be higher. So that's just something to keep in mind. And I'm not sure if that would affect the snap-on like virus or modus. I think it will. So I have to say, it's for me, as I said, I'm still new with this tool, but it's so much easier to use this tool on a Picoscope other than virus or modus. Another limitation of this tool that I don't like is the cords. It's very short. You got a positive and negative lead. There's a green and yellow lead from the tool that you hook up to your lab scope. They're short, like any other snap-on leads. They don't make them long enough. Also, the cables that you hook up that you're going to hook it up to your cylinders, they are short as well. See how I had to kind of angle it this much to get to my far cylinders next to this firewall, number 8 and number 7. That's kind of annoying, but it is what it is. So when you're setting up this tool, just make sure nothing is tangled, make sure everything is secure and away from your belt. Other thing that I also learned, that if you use this tool on direct ignition system with a snap-on, virus or modus, you can only use a negative side of this tool, okay, which limited you to a four cables, okay. Now, if you want to use if you want to see like a V6 or V8, you're not going to be able to do so. It's just you're limited to 4 cylinders, because in a direct, when you set up your snap-on tool and use a direct ignition system, it's only going to use the yellow channel. So in order to see 6 or 8 cylinders, you have to buy another adapter, which is basically a quad cable, kind of like this one, which will, with this cable, you can hook it up 2 of these on the negative side on the yellow channel. Then you're going to have 8 inductive pickups that you can see you hook it up to your cylinders. Now that gets really expensive, so I'm not sure what's the price on this quad cable, and plus you have to buy these inductive pickups as well for each connector, and they are not cheap either. And this can be used also on a coil and plug adapters that Snap-on has. But here's one of the limitations with this tool, is that you got to have these cables to do, if you want to do a direct ignition system on a V6 or V8 engine. Now the beauty of the Picoscope is that you can actually use both sides when you test the V8 or V6, and so we can, because they're going to give us the same waveform signal. So what I have now, I have my yellow channel, it's a negative side, hook up to my bank 1, and I have a positive side, it's going to be the green channel from this tool, on my bank 2. And on my Picoscope, I'm going to use 3 channels. The first channel, channel A, is going to be the bank 1. Channel C, which is actually green channel on Picoscope as well. I'm going to hook it up to my green lead from my SIA. That's going to be a bank 2, and then we're going to need some kind of a sync to be able to identify our cylinders once we got our waveforms. And I'm going to use a signal for cylinder number 1. We can use different things, like on this particular system, I'm going to use a signal from the PCM, just a square wave. It should be like 0 to like a 4 volts, something like that. We can use a current ramp with an M clamp on one cylinder. We can also use maybe another inductive clamp and get the secondary ignition waveform from one of the cylinders. So it doesn't really matter as long as you can get some kind of a signal from your cylinder that you're going to use as a sync, and then we're going to use a firing order to figure out, you know, what cylinder is misfiring. Now this setup, honestly, with the Picoscope, it makes it so much easier. It's not as difficult at all, and this is great for intermittent problems. This is good if you have injector that doesn't you know, maybe doesn't spray enough fuel, or maybe spray a lot of too much fuel. Something else that I noticed that I like, because we can actually divide 2 banks. We can see the signal from one bank and another bank, since we're going to have 2 different channels. And if we have a specific problem on one bank, we can focus on that bank and see what's going on, and it can compare it to another bank. So my firing order is 1, 8, 7, 2, 6, 5, 4, and 3. And this is the 5.3 Z engine. The code is Z on this truck. And so when I'm looking my bank 1, I'm going to have a cylinder 1, 7, 5, and 3. That's going to be my firing order. And on the bank 2, I'm going to have cylinder 8, 2, 6, and 4. So it's going to be a lot easier to identify the cylinders. Now on a Picoscope, I made a custom probe for this tool, and I'll walk you through my setup, and it's pretty easy. And so let's go ahead and just to see what I have. So instead I have my tool hook up, my yellow lead, the negative channel. Negative side of this tool is going to be bank 1, positive bank 2. I have a ground from SIA 2000. You just ground lead, you hook it up to your ground. My channel B is just a regular lead, and I have that hook up to my signal on the cylinder number 1, and then the ground lead goes to the ground. So this is my setup here. Now I did piggyback the ground from my SIA 2000 to my channel 1, channel A, channel C. I piggybacked, and then my channel B, it will be just a signal from cylinder number 1, and there's a ground here for my channel B, and the ground from my SIA 2000. And all you gotta do is just you know, hook up your leads for inductive pickups right there. Now, order which way you're gonna put it, it doesn't really matter. It is nice to separate this positive and negative side on the tool, but you know, once you have your 4 leads, it doesn't really matter which way you're gonna hook them up to your wires, because again, we're gonna use a sync to identify our cylinders. And I actually did use this end, this side of my, to reach the far back cylinder number 6 and actually number 5 and 7 on this side. And again, this is kind of I had to put a little hook here just to kind of angle this. It's just these cables a little bit shorter than they should be a little bit longer. And I kind of looks okay, but once you start hooking up the stuff on another side, it gets a little bit more tight, I would say. And see how on this side, and this cable is a little bit, now maybe I should go underneath this hose, but that's okay. I mean, I got them all hooked up. I got 1, 2, 3, and there's one here. So there's going to be number 2, actually number 4, number 6, and number 8 down the back. So alright, so that's it, and let's set up the Picoscope. So now this car has a slight misfire at the idle. So let's see if we can find a misfiring cylinder. So the first step, I'm going to go to channel A and go to my probes. So what I've done actually, as I said, I made a custom probe, and it's this one here. SIA 2000. So the way this works, it's basically you open up your custom probes, and you can go, you'll go to new probe, and so from here you're gonna set up your probe. I'm gonna go back to a. Just gonna go edit this channel so you should see what I've done. So go next. This is volt. So basically what this is, attenuation on these tools is 1 to 5,000. So in order to get the correct signal, you're going to put minus 5,000, and this is for the direct ignition system. And you set up your scalings at 10 to, that's what I did. You can do whatever you like. And I put 300 megahertz filter. You don't have to do any at all. And you're done. And SIA 2000. And I put like a yellow lead, but that's you don't have to. I mean, that's just what I did. So let's press OK. I'm just going to start it. So first, actually, what I'm just going to use a regular lead, so you guys can see actually what is happening to what the signal looks like, and that's why we have to use our formula to get a signal with the way it needs to be. Now with this formula, our Picoscope is going to calculate our power kV for us, and as I said, attenuation is 1 to 5,000. That's going to be the closest multiplication for Picoscope to figure out our kV. So I'm just going to go to regular channel, and I'm going to go to up to 5 volts, because actually voltage output on these is like between 3 and 4 volts, depends of the output. The my B my B channel is just going to be, that's going to be my signal from okay, there you go. And that's my square wave. That's just a PCM, tells the coil to fire the cylinder. So it's going to be 0 to like a 4.5 volts or something like that. So I'm going to set this at the 10 volts. And my green channel, let's say I hook it up to my green lead from my SIA. It's going to be a little bit easier to follow. And I'm going to set that at 5 volts as well. Okay, so we got 3 channels going, and now we're going to start the car. And now the belt squeaks a little bit, so I'm sorry about that. Okay, so the first way we can do, we can set the trigger on the channel 2. Now the trigger, it's, you don't really need it, because you will have will take a longer time base to capture more data. So trigger, it's not really that important, but we'll do it anyway. I'm going to repeat, just to kind of set up the tool first. And there you go. So I'm going to kind of put it here. Come on. I got spikes from our ignition. It's confusing my trigger a little bit. Be able to trigger. I don't know why it's not doing it. Oh, I put never. Oh my god! I put channel C to go to B. I'm sorry. All right, that's better. Okay, so now let's spread this up a little bit. Now this is my bank 1. We can see the signal is upside down. It's the same thing on bank 2. It is upside down as well. So let's go. I'm gonna check my sampling rate a little bit. All right. Okay, so I can stop this. So we can see now that my signal is like, this is my burn time, and this is a power KV. Everything is upside down. It's kind of hard to see, but that's what's going on here. So now here as well. So I'm going to invert these channels. We're going to go to channel A, and then we're going to use that minus 5,000, and this is going to flip our channel, but at the same time it's going to calculate the KV for us. I'm going to go to 30 kV, that should be fine. It goes now to green channel and do the same. Okay. I'm going to go to 30 kV, and then let's see now. We should have. There you go. As I said, the trigger doesn't work. There's a lot of spikes from these ignitions. Now we can see that we can stop now, and there's one here. So now my waveform is configured the correct way. So now all I need to do is increase my time base, and as I said, this has a slight misfire at the idle, so I'm just going to go to 500 milliseconds. That is my This is my signals here, and we can see my trigger up on the top on the red channel, and we're just going to use that as a sync now. And let's do one more. Now we can stop. Okay. Okay, so now I can go back. I'm gonna get the red channel down. Get these two. So remember, this is my bank 2. This is my bank 1. And what I like to do, instead of zoom in, this way, I actually like this feature here, that I can kind of horizontally zoom in my waveform, and then I can just kind of go through each of the. There you go. See how nice that is. And so now this is my trigger, and now we can identify the cylinders. There's my. I should have eight firing events here. So 1, 2, 3, 4, 5, 6, 7, 8. So I got all 8 cylinders on the screen right now. Now this is the firing order will be 1, 8, 7, 2, 6, 5, 4, and 3. So and when we look like if you want to look the bank 2 only, there would be 8, 2, 6, and 4, and on bank 1 will be 1, 7, 5, and 3. And that's that easy. I mean, that's what it's the beauty of the Picoscope, that you can set this up a lot faster. And now all you gotta do is just go through the buffer and see if you can spot any problems on any of these cylinders. Now we can zoom in a little bit more if you want. This is 20 times to 50 times. I think 20 times will be fine for now. We should be able to find a cylinder that's giving us a problem. And of course, we can rev the engine up and capture data as well, and then zoom in as well. So far everything looks okay. Sorry about the clicking noise from the mouse, but and this is what I like. You can now you can divide your banks, and if you have a specific problem with one bank, you can find your problem. So far I don't see anything. Okay, that's one buffer, that's one. Okay, go number 3. I have to go this way now. I may have to warm up the engine, see if I can get the this glitch. So far everything looks okay. Okay, I'm gonna warm up the engine and see if I can find the glitch. Okay. Okay, I had to warm the engine up, so I put it in a gear actually. I just got it for the video, and I don't want to bore you with all that, but let's. This is the second capture that I've done, and let's see. Here's one. This is a nice one. This is a number 3 on a bank 1. Now we know the blue channel is bank 1, and this is my number 1 cylinder. And then you go backwards. You go to 1, 7, 5, and 3. But if you go backwards, it's gonna be 3, 5, 7, 1. So this is cylinder number 1, and now this is a clear example of a problem with the plugs and wires. This is outside of the combustion chamber where a spark kV, and actually you can see the power kV is a lot higher as well right there, and so it was like this is a 12 kV, but here's the spark kV. Let's see, 2.4. Now this is not always exact, you know, these numbers, but that doesn't really matter. What you're looking for is this problem here. When you see this, let me kind of zoom this in now. This is where you have an open. This is outside of combustion chamber. Basically, this spark kV, it tells you that it needs more energy to jump the gap on the spark plug, and at the idle, the compression and fuel mixture ratio should not change. So there should not be reason for this spark kV to change. Now, you know what? It would be ideal to actually see that spark kV on every cylinder. So right now you don't even see it. It's just the nature of the signal that you're going to get, and it's going to be different every time. But the beauty of this system is you're going to be able to compare to other cylinders, and clearly you can see a problem here. So every time you see this, it's going to be a spark plug and wire. Sometimes it can be a coil, but on this system, near the if you see this on the multiple cylinders, you know you're going to need to change spark plugs and wires. Let's see if I can find any other ones. So that was number 3 on bank 1. So here. So now we can kind of focus on this cylinder here. This is what I said. This is so nice when you divide your banks. Now I've seen this is my sink, and this cylinder was kind of giving me a problem. I can actually focus to this one now. Here's okay. And this one, actually number 1, it does a little bit as well. You see that. But if you see this on the multiple cylinders, you just this is a nice one. It's right there. See that? So this is on bank 2, and so this is my sink. So the first on my firing order is going to be number 8. So number 8 cylinders actually have a problem as well. The same issue, plugs and wires. So this is going to be 8, 2, 6, and 4, and I'm going to sink again. So it's a 4 cylinders on bank 2. And I really like this. I really do. And I thought that would be better to have everything on one channel, but actually, you know, I like this better. I really do. Be able to see different banks, and if you have maybe a problem with fuel tree and it's elevated on one side versus another. It can be a problem with the fuel injectors, and you can easily see that on your ignition waveforms. And but that's what, as this engine warms up, you're gonna see these glitches more and more. But that's what you look for. And now, of course, if you have a problem at the idle, you don't have to rev the engine up. You just let it run until you find your problem. If you have an engine under load, then you're gonna snap throttle and maybe put it in the gear. Put some load on the engine. There's one. This is a nice one here. And this will be number 7 actually. See how that jumps from one cylinder to another. The multiple cylinders having problems, and this is clear indication of the plugs and wires. This is very nice. See that? How powerful the Picoscope is. Okay, so now I'm gonna unplug the injector. So this is number 1 now. I'm gonna unplug injector and see if you can identify which one did I unplug. I'm just gonna let it run again. And now with the lean misfire, we have to rev the engine up. You're gonna be able to see that at the idle. So let's just demonstrate it real quick. I'm going to unplug the injector now. Okay, I've got injector unplugged. I'm just going to stop this. You can look at the waveform at the idle, and then we're going to rev it up. Okay, I'm going to zoom in, zoom out. Alright, so when we look at these waveforms, we really can't see much at all. They're pretty much the same. There's a little bit here. A little bit here too. That would be number, this would be number 4 actually, 8264, yeah, 8264. A little bit here too. This is the same. Let's see it here too. Okay, so now we can actually see the number 4 on bank 2. It changes a little bit. It's this one here. And I'll tell you guys, this is the injector that I unplugged. So there is actually a little bit of changes even at the idle. You can spot this a little bit right there. You can see a little bit slope up actually, but it will be more pronounced with a wide open throttle test too as well. It's actually pretty interesting. I didn't really expect to see any difference at the idle at all, but there's some right there. Okay, there you go. Almost every time you can see it a little bit. That's it right there. So okay, let's do the wide open throttle. This is interesting actually. I really didn't expect to see much of a difference in the waveform at the idle at all. I'm just going to get rid of this sink. I mean trigger. I don't need it. Okay. Okay, so when you do wide open throttle, what I do actually, I kind of look at the screen, and looking when the new screen comes up, you know, I would rev it up. If you don't want to do it at the end of it, because you're gonna miss your events. And it's kind of interesting that you still have one signal from the PCM, even though basically the power was cut off on the injectors and coils. Okay, so let's see here. So this is wide open throttle. See what I did actually? I was waiting kind of for my waveform to come to here, and then I rev it up. So now I can have the full event on one screen. And now we can zoom in. I can actually look here to know exactly when it's my wide open throttle. It should be kind of this area. Okay, so let's see now. There's a little more. Okay, so here's this kind of indication of the problem with those plugs and wires. See how the power kV went so high, and so we're gonna concentrate on this one here. That's it. Let's see here. Down. And here's my lean misfire. That's very nice. Look at that. That's a high resistance. Let's see how far my kV went up, because the high resistance I cannot even measure it anymore. That's a very nice capture. And my burn time is a lot shorter. That's here too. Here too. This is a nice one. I mean, we can clearly see a difference. Now, this is, as I said, this is a nice thing about using this way, because now I can kind of down and just look at my bank 2, and I can see we got 1, 2, 3, and 4. Now I can see that one of my cylinders has a lean misfire. And by using the sync, I can identify my cylinder as being 2, 6, 4. I mean, I'm sorry, 8, 2, 6, and 4. Oh, look at that. It's pretty cool. There's one here. Wow, look at this. Wow. Right there. Here. Well, that's how easy it is with this setup to find a, like a lean misfire. I mean, look at that. It's just so obvious. It's crazy. Look at that. It's just okay. Well, you guys can see a point. I just want to show how useful this tool is, and how easy it is actually to set up on a. I know this is a D-cell. Set it up on a Picoscope, and you can see this is a D-cell here. Okay, and I'll just show you guys that I unplugged cylinder number, injector number 4. Just gonna go over there real quick, but and let's see here. So here's my number 2. Here's my number 4, and then I got number 6 and number 8 in the back there. Yep. 8, 6, 4 is unplugged. There's 2. Okay. Alright guys, well I hope you guys enjoyed this video. Now this setup, of course, you will do this and when you really have a hard time to pinpoint your misfiring cylinder or cause of a misfire, if you can do power balance test by simply unplugging the coils and find your misfiring cylinder and change the coil or spark plug or something, of course you're going to do that. But in some cases where we really have a hard time to identify the misfiring cylinders, and sometimes PCM can actually identify the wrong cylinder that can really screw you up, this is a great way of finding that problem. As I said before, on the snap-on tool you can do it as well. The only problem again is that you can only use the negative side of your tool, and then you have to buy more adapters. Now on the snap-on you can actually you can use both negative and positive leads by simply going into a lab scope instead of a ignition scope. You can just go to a lab scope and do pretty much the same thing what I did with Picoscope. Just deploy 3 channels, 1 channel from your each. We're going to pause the negative side of your SIA 2000. The 3rd channel is going to be your sync, and you can do the same thing with a Varus or Modus as well. Again, the Picoscope, it is a lot faster and resolution is a lot better, but it's possible to do the same thing with the snap-on tools as well. And if you guys want me to, I can make that video, show you guys. Again, it's not going to be as good as Picoscope, but it still can be. You can still use them. And I'll see if I can find. As soon as I get the opportunity to get a car with a V-Spark system, I'm gonna do this as well. And then we have to identify positive and negative firing cylinders and all that kind of stuff. But again, that's something new for me, so I will definitely, as soon as I get the car, I'll do that. Okay, I'll stop talking now. And okay guys, I hope you guys enjoyed this video. I really like this tool. Has some limitations on it, but they're still very useful in diagnosis. So again, what I really hate about it is just that these leads are too short. They should make it a little bit longer. It would make this job a whole lot easier. So, alright, it is what it is. Well, thank you guys, and see you next time. Bye-bye.